Good evening, students. So now we are going to discuss about dielectrics. So what are dielectrics? Actually, basically the dielectrics are insulators. Okay, insulators are known as dielectric. Why insulators are known as dielectric and which kind of behavior they show? This is what I am going to tell you. So already you know that insulators are non-conductor. Okay, so they cannot allow the electricity to pass through it. But there are few kind of insulators which by themselves are not polarized by the electric field, but they allow the electric field to influence the other material, or they allow the electric field to pass through it. Okay, that is why insulators are also known as dielectric. Okay, so which kind of behavior they show or why we call it dielectric? So the definition of dielectric I have written. A dielectric is a substance which does not allow the flow of charges through it, but permits them to exert electrostatic force on another through it. So this is what I was telling you. Dielectrics by themselves are not allowing the field, or the effect of field is not applied on the dielectrics, but the dielectrics are allowing the electric field to affect or to influence the other material. Which an insulator which can be polarized through. What is the meaning of polarization? The meaning of polarization is to create the dipole moment. Okay, if a particular kind of material is polarized, so we can say it is showing the dipole moment. Okay, or the dipole moment has been exerted on it. So through a small localized displacement of its charges. So how this will behave, or how to make a dielectric, this is what we are going to study. The dielectrics can be glass, wax, water. All the insulators which we have studied all are dielectrics. So students, we have categorized dielectric on two categories. One is polar, another one is non-polar. By the name polar, you can understand this, that polar means that there is permanent dipole moment. Polar means permanent dipole moment. So such kind of insulator, the dielectrics, even in the absence of electric field, they are able to show polarization, means dipole moment is always present on it. So I have given the example like HCl, that is known as polar dipole, okay, or polar dielectric material. Why this is polar? For understanding this, here is hydrogen ion, here is chlorine ion, and you can see there is a permanent dipole moment, and dipole moment is always from the negative to the positive. So we have shown the direction of dipole moment. Actually, the polar dipoles are, or the polar dielectrics are asymmetrical. Okay, there is not a permanent shape, or these are asymmetrical. That is why they are permanently getting polarization. Why this happens? For understanding this, because they are asymmetrical, so all the center of positive charge and all the center of negative charge are not coinciding. The polar dipoles or the polar dielectrics are, if the center of all the positive charge and the center of all the negative charge is not coincide in a same point, then such kind of materials are being made. So HCl, all the hydrogen ion, positive ions, okay, center, and negative ion center are not coinciding, are not on a same point. That is why, because we have studied one formula for dipole moment, P is equal to Q into 2L. So where Q is either charge into 2L is distance between the charges. So students, we already know, if there is a separation between the charges, one plus ion is here, one negative ion is here, and there is a little distance 2L, then there will be a dipole moment. So here what is happening, 2L is not 0, 2L is not equal to 0. So there is a distance between the center of all positive charge and center of all negative charge. That is why they are permanently showing the dipole moment. So such kind of dielectrics are known as polar dielectric. So one example is HCl. Another example for polar dielectric is, I have chosen is water. So you can see between the oxygen ion and the two hydrogen ion, the angle between these two is 105 degree. So because of this, all the center of all the positive charge and center of all the negative charge is not aligned on a same point or are not coinciding. That is why, because I have shown it that the angle between these two is 105 degree. That is why they are having a particular distance, so 12 is not equals to 0. So these are permanently showing the dipole moment and known as polar dipoles, okay, or polar dielectrics. Now students, we can learn this number, this figure, and this is the total dipole moment shown by a particular water molecule. So water molecule shows 6.1 into 10 power minus 30 coulomb meter dipole moment, which is considered to be a very greater number. Now students, let us proceed for the non-polar dielectrics. So what are non-polar dielectrics? These are symmetrical in shape. What is the meaning of symmetry? The meaning of symmetry is the center of all the positive charge and center of all the negative charge is coinciding on a same point. So how this happens? For example, I have taken the example for carbon dioxide CO2 molecules. Suppose, okay, all the positive charge is here, negative charge is being aligned here, okay. So what will be the, suppose this is how I have shown. So what will be the center of all the negative charge? The center of all the negative charge is here on the carbon molecule, and center of all the positive charge is also on the carbon molecule. So suppose we have to calculate the dipole moment. So P is equal to Q into 2L. So we can see charges are present, but the distance between the center of positive charge and center of negative charge is how much? That is 0. So P is equal to Q into 0. So the net dipole moment is 0 coulomb meter. Okay. So we found that in the absence of electric field, the non-polar dipoles or the non-polar dielectrics do not show any kind of dipole moment, and the polar dielectrics, in the absence of even the electric field, they shows the dipole moment. So that's why they are known as polar and these are known as non-polar dielectrics. I hope you understood this. Thank you. God bless you.